All right, to write the formulas of polyatomic ionic compounds, something we have to understand first is that what polyatomics are. Polyatomics are multiple atoms that combine together and have an overall ionic charge. And we have this chart on the back of our periodic table that gives us that list. Now, when we go to take the name and put it in the formula, we have to recognize that there's a polyatomic present. How do we do that? Well, most polyatomics end in ate or ite. And that would help us recognize that we need to look at the back of our chart to find out which elements are together to create this compound. Now, some of the polyatomics do end in ide, and they're a little bit trickier to recognize, but the more that you use them, you'll start to recognize which of those they are. So in this particular example of magnesium phosphate, the ATE ending would tell me that I need to look at my polyatomic chart. So phosphate, if we look at our chart, is PO4 with a 3- charge. So I'm going to write that down. Magnesium, this just comes up from the front of our periodic table. Magnesium has a 2+ charge. Remember, these charges need to be in balance in order to combine properly. And so a 2- and a 3-, well, I'm going to need another phosphate and another 2 magnesiums in order to balance this out. And so this formula would end up being Mg, I need 1, 2, 3 of them, and phosphate, and I need 2 of them. Now, when I write the formula, I can't write PO4 2. It almost looks like there's 42 oxygens. So I do need to remember to put in my brackets, and this indicates that there's 2 of this entire molecule. Another example we might see is something with a multivalent, where this is cobalt. This Roman numeral tells us we're dealing with cobalt 2+. Nitrite, ITE ending, this would tell me I'm dealing with a polyatomic. I now need to look at the back of my chart. Find nitrite, it's NO2 with a 1- charge. I need to balance out these ions. So there's 2+ over here, which tells me I'm going to need another nitrite ion. And so when these combine together, I would have 1 cobalt for every 2 nitrites. Now, again, I can't make it look like there's 22 oxygens, and so I put brackets around to indicate there's 2 of the nitrite ions present.